Okay, Jim, I may have found a problem with our last setup. I was running 1K audio signal, and I'm going to do it now at 20 hertz. So it's a little different, and I think I'm finding what you are seeing on your scope. Once again, it's high frequency, maybe sine waves that are outside the audio band, so you're not going to hear them. Distortion is still very low, so anything in the audio band is still very low. And I think you've determined that clipping, or this kind of additional modulation that occurred close to clipping, is happening at 35, 36 volts. I'm not seeing it quite there. I'm seeing it at about 38 volts. And whereas it's still, the distortion is just fine and it sounds just good. It should be perfect. Okay, let me show you the screen at 3.1. This is at 20 hertz. I'll turn this guy up. Okay, so there's 33.1, 3.1, perfect, very good distortion. Output voltage is 38 volt. Output voltage is 38.5 volts. Very low distortion right there. No sine wave going on. Then at 3.2, you can start to see a little bit of weirdness here, a little bit of weirdness right there. Okay. Then you get more and more. Like there's 3.4. There's 3.3. So there's 3.4, 3.3. There's 3.2. There's 3.1. Down, 3.1 looks pretty good. 38 volts. Okay, so I'm going to turn that down now. Give it a little rest. Now let's look at the scope, at the oscilloscope. I'm going to move this, so bear with me. Sorry. Yeah, it's not very good. You're getting some aliasing due to the screen. Maybe it's okay. Okay, I'm going to turn this guy on. Okay, I crank this guy up, and right about 3.1, I start to see a little bit of weirdness right there and right there, and I think that's what you're seeing. Okay, and then at 3.2, it kind of spreads out actually. Okay, and then, but you can still see it. There's 3.4, for example. Okay, I'll bring that down, and I'll get a little straighter shot of the screen. Okay, let me get the reflection out of there. Sorry, it's not very good. Here, let me pause. No, I can't pause it. Okay, let me go turn this light out. Maybe we can see it better. Okay, so I'm going to put this down here. Sorry about that. Be right back. Okay, we're going to try this again now. Okay, having trouble here with this light. Maybe I'll turn this guy on. Okay, there we go. That's a little bit better. Okay, I'm trying to get this thing better here. Okay, so I'm going to crank this thing up, see if this will work. There's 3.1. So you can see right there, there's a little bit of hash. 3.2, it gets, there's 3.10. Now, 3.0 is no problem. Okay, let me put this back, excuse me. Okay, okay, 20 hertz, I do see some hash. It's not in the audio band. It's outside the audio band because my analyzer would detect it. Anything in 20 kilohertz would be detected by my audio band, and it's not. The distortion is very, very low up till 3.1, 3.2 volts, which was right around, as you can see, 40 volts. So I think that we've discovered the problem in that you're reading on your scope where you thought 1% distortion was occurring, but you actually have to take the average of that signal, do some additional filtering going on, and take the average. And when you do take the average, you aren't seeing any distortion in the audio range. What's happening is the switching frequency is dropping, and we're seeing more switching frequency ripple at that voltage. And because of the modulation, as the modulator gets close to the clipping threshold, the switching frequency is changing, and it's dropping quite a bit, still well above the audio band, like 200 kilohertz, for example, but is enough to show it on the scope with your oscilloscope. But like I said, it's not in the audio band, and it's not your 1% distortion number, and that's really what we were trying to figure out. That's where you're starting to get clipping. Hopefully that makes sense. Let's go through this one more time. I'm going to show you the screen. Okay, so there's our screen again. Excuse me, I'm going to bring this down, move this over so I can get a better shot at this. Let's see what I can do. Maybe I can do this. Okay, there we go. Okay, so now I'm going to go over here. I'm going to crank this guy up. So let me just shout out. There's 3.1. Okay, that's where you started to see that little hash. Distortion super, super low, 0.005. There's 3.2 at 20 hertz. No problem. There we go, 3.3 in this case. There's 3.4, 3.5, 3.6, 3.7. So it's a little bit better than I measured on Sunday, and I bet it's because my AC voltage is better. So give me a call. I think we're getting to the bottom of this. I'm going to put this once again on the Tweaky sites, and hopefully you can download it. Okay, talk to you later. See ya. Bye.